Well, good morning, everybody, and welcome to Sun and Fun. I'm Ed Wischmeyer, and boy, is there some reflections from something out bright sunlight. Anyhow, I'm going to be talking about expanded envelope exercises, and you can see on the picture that that's a general aviation airport with general aviation airplanes. So this is the pilot community we're addressing, general aviation pilots, to do their training in the same kind of planes that they're already flying. Now, AOPA did a wonderful introductory video, so we're going to let them run their video. And we'll be back in 3 minutes and 20 seconds.
So you can fly to practical test standards, airspeed, bank, altitude, smack on. That's what the FAA wants, and that's what your CFI teaches.
But does that really prepare you for the real world? Does that give you the skills you need to get out of trouble? Well, maybe not.
But when you focus that much on the parameters of flight, you neglect the sensations. So then if you're in a flight situation where the sensations start to come in and those sensations are unfamiliar, that can degrade your performance.
Ed Wischmeyer studies loss of control accidents and based on what he's learned, developed something he calls E3. And that caught the attention of AOPA Air Safety Institute boss Richard McSpadden.
So Ed, to start with, can you summarize for people what is E3, Expanded Envelope Exercises? What is it?
E3 is really a philosophy and, of course, a bunch of exercises. And the idea is that pilots don't have accidents in their comfort zones. So if you can extend a pilot's comfort zone, that is their flight envelope, if you can expand that, then there will be more comfortable pilots, there'll be safer pilots, they'll get more joy from flying, and they'll probably fly more. So E3 is a philosophy that says, don't stop at the mechanics of the ACS or the regs or anything. Go beyond those and really see what the airplane will do and enjoy it.
Well, Richard explains more about E3 in his Safety Spotlight in the upcoming April issue of AOPA Pilot Magazine. And E3 exercises will soon be added into ASI's Focused Flight Review curriculum.
They're not really exercises with precise entry and exit parameters. That's not really the goal. The goal is to get a little farther outside your typical flight regime and just feel what that's like so it doesn't surprise you if you ever find yourself there.
Well, there are many different exercises designed to safely help you learn the feel of your airplane when it gets outside of your normal operating envelope.
Certainly the poster child for E3 is what I call the 60-90s. You start in the plane at a speed comparable to flying downwind in the traffic pattern, and you're at altitude and with flaps retracted. Using full aileron deflection, bank to 60 degrees, turn 90 degrees of turn, then full aileron deflection the other way, turn 90 degrees, so it's left, right, left, right. But what's different about this is you don't worry about airspeed, you don't worry about precise bank angles, and you don't worry about altitude so that you can focus on the sensations and see how much is going on rather than being distracted by airspeed and altitude.
Well, other exercises help pilots learn how to deal with botched base to final turns. Well, Tom, I'm looking forward to learning more about those exercises and going out in the 170 and trying them.
Yeah, it does sound like it'd be an interesting exercise. And the important thing is, to always remember that the FAA minimums are just that, and that we all need to kind of expand our envelope, if you will, and understand the sensations of the airplane and be able to go out and be safe flying the airplane pretty much in any part of the envelope.
All right, now, how many of you folks know what an air cam is? A few of you, good. If we have the air cam picture, please. I was talking to the air cam people, and you'll notice the pilot is sort of like sitting in a canoe with a motorcycle windshield and an airplane following somewhere behind. This is sensory overload, and the point I bring up, since that video was talking about sensations, when they go to the factory for training, they'll spend the first half hour or hour just flying around, getting used to the sensations so that they're not in sensory overload. So, little added tidbit from just this morning. Okay, so what's E3 all about? First of all, it's having fun. If it's not fun, I mean, hey, let's face it, who's gonna do it? It'll help you be a better pilot and a safer pilot in your own airplane. You don't have to go somewhere else and rent something that's not going to fly like what you fly. And what are the expanded envelope exercises? They're exercises, not maneuvers. So what this means is we're going out to feel the sensations. We're not worrying about the instruments. And Richard pointed that out. Depending upon who you talk to, people will say that we only fly in 10% of our airplane's flight envelope. Some folks will say we only fly in 5% of our envelope. So what this says is there's this whole other part of the flight envelope that we never see. And if we do happen to be there and we're overwhelmed by sensations, that can be bad news. The phrase I use is cognitive availability, meaning you can still pay attention to all the cues you've got. You can pay attention to the gauges, you can pay attention to the sight picture, you can pay attention to the control field because you're not overwhelmed with all these kinds of distractions. And goodness knows the aviation psychologists will tell us, that there are a dozen or more different kinds of distractions that can, do bad things to our skills. So we want to maintain cognitive availability in these unusual situations and continue to fly the airplane. And there's been a ton of background research that's gone into this, including reading 700 NTSB reports in detail. Not the summary, not the narrative, but when necessary, going back into the docket and looking at the digital flight data. A last point is E3 does not teach techniques. There's plenty of things out there that'll teach you how to do this and how to do that. We're looking to look at the sensations so that you become acclimatized to the sensations. So in other words, E3 complements other flight training. Regular flight training has completion standards. Do this with so much bank, so much airspeed, so much altitude. And they'll teach specific techniques, like the ACS will say, here's how to recover from a stall. But what you find when you've only got that level of training is that when you get near the boundaries of your comfort zone, your skills degrade. And accidents don't happen when people are in their comfort zone. Accidents happen when people are out of their comfort zone. So if we look at the expanded envelope exercises, as I've said, we're looking at the sensations, not completion standards. And we can see that the airplane is not limited by specific techniques. Your CFI or some book may say, this is the way you do a stall recovery. My airplane hasn't read any of those books. And when you've gone through E3, you're more comfortable with more of what the plane can do, and we're increasing our overall cognitive availability. So let's go into that more in detail. Here's flight training, and on the left you can see the traditional flight training, and on the right you can see all the loss of control. But there's this whole middle area that nobody talks about, nobody teaches, or maybe somebody will mention a little bit of it here and there, but it's really not emphasized. And that's where the loss of control precursors come in. So that's where E3 focuses. So here's the 60-90, and you saw this in the other video, but here it is again. So we're going to go full aileron deflection. Lots of folks have never used full aileron deflection, and there have been some accidents, some crosswind landing accidents, where perhaps people didn't use the full crosswind capability of the airplane because they only knew how to go halfway with the ailerons. So this is a lot of fun, and this is one that almost nobody gets right the first time, and almost everybody says, can we do it again? And so when you've got that kind of flight training, can we do it again? You know that it's being effective. Now, E3 had its original goals on the left side, accident reduction and cognitive availability and fun. But we found that there were a lot of benefits that we didn't really anticipate. It boosts pilots' confidence. It's interesting to see pilots fly out on an E3 flight like little old ladies, and they come back, and they're in control of the airplane, and that's a good thing. It reduces the fear of the unknown. It's interesting to me, and I don't have data to support this, but there's a lot of data that suggests that loss of control has fear as a component. So people get into a fearful situation, they contract into their comfort zone, and they don't take advantage of what the airplane can do. Since I've done most of the E3 flights in my RV-9A, and pilots, come from Cessnas and Pipers and such. It's interesting how much E3 helps pilots develop a feel for the airplane. Now, that's not the design purpose, but that's an interesting side benefit. Similarly, overall pilot technique improves because pilots have more cognitive availability, more ability to pay attention to flying the airplane. Situational awareness increases because when pilots aren't obsessed with the airplane here, they have more brain cycles to look at the big picture of situational awareness. Sometimes you find gaps in training. Well, E3 is not going to address those, but it will find some. And E3 is transferable to other aircraft. Once people have this attitude and this confidence, that will transfer. And of course, it motivates more flying. Now, E3 does not duplicate other flying, and this is deliberate. There are plenty of places where you can learn how to do a flight review, plenty of places that will talk about an aircraft checkout. So we want to keep E3 on what E3 does. And we want to certainly avoid any peripheral issues like, there was that big debate about the practical test standard versus the airman certification standards. Let other people worry about that. We're going to worry about E3. But as I've mentioned, elements of E3 can be borrowed to support these other initiatives. And for those of you who are in the airline world, E3 has absolutely no relationship to the extended envelope training. Absolutely none. So, loss of control is more than stall spin. This graphic is from Mike Bromfield, who was at the time at Coventry University in England, and now is, I think, I forget where he is, Manchester or something. But you'll notice the two yellow blobs in the middle. The top one is stall, and the bottom one is unusual attitude in pitch, roll, and yaw. Those interact, and both of those feed into loss of control. On the left are the triggers in light blue. The one that we're concerned with is the top one, intentional or unintentional pilot input. This is what Ron Wantaya refers to as pilot miscontrol. So this is Mike's view of loss of control, a bigger picture than you're going to see pretty much anywhere else. But there are also, I found, 2 research papers that say the same thing. One was a NASA research paper, and another one I forget the details of. But the bottom line is that if we're talking loss of control and we stop at stall spin, we're not covering all the bases. We're going to miss a bunch of bases. So here is a wonderful quote. And let me talk about the authors first. There is this discipline called safety science, which is analyzing accidents, not just aircraft accidents, but a lot of it comes from the nuclear power industry. So you're looking at cultural events, you're looking at management factors, you're looking at training, you're looking at fatigue, you're looking at the whole spectrum. Out of that came HFACs, which the HF stands for human factors. And Wigman and Chappell are 2 really, really big dogs in that field. And here's 2 sentences, throwaway sentences in their 20-page document describing HFACs. You've probably read this already, but look at the 2 underlined words at the back. Attention failures. The difficulty with these highly practiced and seemingly automatic behaviors, takeoff, turns, is that they are particularly susceptible to attention failures. So if there's something you do all the time and you get distracted, here it is straight from the horse's mouth. Those routine maneuvers are very, very susceptible to attention failures. So let's look at the base to final turn, and this will be a fun exercise. You're flying along, fat, dumb, and happy on base, and all of a sudden you decide that you need to tighten up your turn to final. So you can focus on the runway alignment, and if I'm focusing on the runway alignment, guess how much attention I'm paying to pitch? Probably not a whole lot, because I'm paying attention to the runway alignment. So in this video, pay close attention to where your eye is drawn. Look for a specific point, not a general point, but a specific point. Okay, where is your eye looking? Where is your attention? Well, along about here, the smart thing is to go around, which I did, but where is your eye focused? Where was it focused? Runway. Where on the runway? Threshold? Okay. Now, questions for you. In this video, how much did the bank angle change? What was the pitch angle? How much did the pitch angle change? Was anybody paying attention to that? Yeah, about right. It was a very gentle and constant turn, but the point is that when you're focused on the runway, these other things you're not paying attention to, you become cognitively unavailable because you're spending too much attention on the wrong thing. So, if we want to avoid this perceived need to make a steeper turn, how many of you people were taught don't ever overshoot final approach? Only 4 of us? Boy, you guys did better than I did. So this can induce a fear of an overshoot and result in unnecessarily steep turns. True confession. A few months ago, I was flying my RV-9 and I was on base leg with a tailwind, fat, dumb, and happy, and put it into a standard bank. And I was going to overshoot the runway. And my first reaction was, tighten up the turn. I'm doing research on this topic. I'm doing presentations on this topic. I've been flying for 40 plus years, and it still got me. Ugh. Okay, so on E3, we want to experience the base to final turn overshoot sensations. So when we get those sensations, they're not going to blow us out of the water. We want to safely explore the base to final overshoot, and our attitude should be, overshoot is an oops. It's not an emergency that requires drastic and unsafe action. So here's the E3 exercise for runway overshoot and alignment. So we'll start at 2 miles out, more or less on the glide slope. And this is higher than turns around a point than you do in the private pilot curriculum. So we've got that base covered. And then we will fly on base and not start to turn final until we cross the runway center line. That is a guaranteed overshoot. There's no doubt about it. And then what we do after we overshoot the runway center line, we won't align with the runway. We'll find a point on the other side of the runway and align with that. And then a point on the other side of the runway and align with that. And then at a safe altitude, we'll align with the runway and go ahead and make our landing. So what this isn't something radical and new and dangerous. These are S-turns on final that we've all done. It's just we're paying attention to the ground reference. And then just for practice, we will land off-center on the runway. And again, just to do something different to break habit patterns, if we can, we'll come to a full stop on the runway. So here's the deliberate runway overshoot. Nothing to fear. We've just crossed the runway center line. This is Savannah Runway 1 for those of you who are interested. And yeah, we overshot. So now we will go align, not with the runway, we'll go align with something 100 yards off to the left side of the runway. So coming up on the runway center line, yep, this runway center line, yep, we have overshot this way. So now we'll go back and we'll overshoot the other way. And so this is different sensations, but in terms of pilot technique, this is a so what. These are the most gentle S-turns you could ever ask for. Okay, so now we'll come and we'll start aligning with the runway, and we're going to land 2 expansion joints to the left. Along about here, Tower says, can you make the first turn off, please? Okay. So a little bit of crosswind, a little bit of thermal. As you can see the plane wobbling around a little bit. So now, again, we're doing this for the sensations of landing off-center. There's our expansion joint, little gust. Right wheel, left wheel, nose wheel. A little bit of brakes to take the first turn off. And then we have to also think about runway incursions and taxi errors and all that. So here's the first turn off. And try not to notice that I'm off the center line of the taxiway. You guys didn't see that, it never happened. But once we get across the whole short line, that's when we've got time to clean up the airplane, to do whatever our procedures are, and to check for traffic. so that, for example, we don't get run down by a Gulfstream G500 prototype crossing the runway there. Okay, any questions on the runway overshoot exercise? Yes, sir. Well, his comment was he'd never heard of don't overshoot, and all I can say is good for you, because there's lots of people who are in the other thing. So now let's talk about 4 ways to botch a base to final turn if we try to tighten up the turn. And this is from some of my research, and I've not found this in the literature. But if we try and tighten up the turn and we put in a lot of bank angle and we don't put in enough back pressure, that's a steep turn without enough back pressure. And what is that, everybody? Yeah, nose comes down. Now, it turns out that this phenomenon of a steep turn and the nose coming down is very, very much like an incipient spin in a lot of airplanes. So suppose you're in a turn and the nose is coming down and you think spin, and you push the wheel forward. That's even worse. Now, the third case, and this is one that you'll read about a lot, is we'll be turning base to final, and you'll say, we need to tighten up the turn, so we'll put in a whole bunch of rudder, we'll skid the airplane, we'll pull back on the wheel, and we'll do a spin out the bottom. The fourth case is a lot of bank, some back pressure, the nose starts to drop, top rudder, and a spin over the top. Now, what's interesting is these 4 cases all have the same cause, a perceived need to tighten up the turn. So people focus on tightening up the turn and think they have to do something, and they lose cognitive availability. So this is what A3 is all about, being able to pay attention even when things are looking a little not quite as they should be. Now, I mentioned the low-speed spiral. Here's a demonstration done at altitude. And this one is 60 degrees of bank and 30 degrees of nose down, normal category airplane. So here we are, and of course we're way slowed down. There's the nose coming down, there's 30 degrees, and there's a prompt recovery. Anybody want to guess how much altitude was lost on that one? Anybody? 300. 300, do I hear 400, do I hear 400, 300, 300, 300, 400, 400, do I hear 500? Anybody for 500? Do I hear 600? 1,000. That one lost 475 feet that quickly. And when I do these demonstrations, I typically lose 500 feet. The range that I've seen is 400 to 800 feet. So a low-speed spiral can happen in exactly the same circumstances as a spin base to final. It can fool the pilot, and nobody really pays attention to these because they're not known. So are they real? One of the studies I did was looking at 551 RV series accidents, and look at the 3 bottom boxes on the left. These are pure loss of control, not loss of control after hitting a bird or something like that. So we had 7 that were very clearly low-speed spirals if you went in and read the NTSB narrative. 13 might be either, and 4 were stall spin. So this doesn't say that low-speed spirals are twice as common as stall spins. What it does say is they are significant. So if we're only looking at stall spin and neglecting low-speed spirals, we are missing a whole slug of loss of control events. So how are we going to manage risk when we're doing all this wild stuff? Well, first of all is FAR 91.3A, which everybody probably knows, if not by chapter and verse. But the pilot in command is the ultimate authority. So just because somebody else did something similar in a different airplane doesn't mean that you can safely do it in your airplane. And E3 risk should be no more than commercial maneuvers. We don't do any stall spins or anything close to stall spin in E3. Most of E3 is flown below VA, below maneuvering speed. So we've got lots of cushion in terms of aerodynamic structure. We fly almost all of E3 with the flaps up. And there's 2 reasons for that. One is that you don't want to overspeed your flaps. And second, many airplanes have a 2G flap limit. So we're paying attention to the airplane. Now, if you're flying a retractable gear airplane and you're doing the low-speed spirals, you'll do those with the gear extended because that will keep the speed from building up. The last thing is the low-speed spiral is only demonstrated. We don't ask the student, if you will, to do that. And I've had some very, very experienced pilots not want to see a low-speed spiral. I've had one guy who does checkouts for a type club who did not want to see 60-90s. So what this says is those pilots who are in positions of high visibility and high responsibility were flying with a restricted flight envelope. So what does it take if you want to teach E3? One, basic instructor competency beyond Part 141. If all you've seen is how to fly the book and fly these exercises, you haven't paid enough dues. And similarly, you want to have seen E3 before you teach it. After all, nobody should teach mountain flying from reading the book, and nobody should teach aerobatics from just reading the book. And what airplanes are suitable for E3? Any normal category airplane with good stall spin characteristics. So we've flown it in a whole bunch of planes, and when we flew it in a Beach Baron, no surprise, we didn't do any of the stall exercises. But you do want to double check your POH in case there are any limitations. And I'm happy to say that the Air Safety Institute is incorporating some of E3 into the focused flight review. And there are other things that are in discussion, but I think you'll understand that COVID sort of blew a lot of projects out of the water. So next steps for E3. Industry-wide, make this so that low-speed spiral is not something, hey, I heard about it at Sun and Fun, but something that everybody knows about. In the same way that you read that go-arounds should be taught so that pilots aren't afraid of them, I think that deliberate runway overshoots should be taught and practiced every now and again. So you say, okay, I know what this looks like. It's not a big deal. There's always room for refinement in E3. And ideally, we'd have an E3 users group so people who have different experiences can share them, and different E3 instructors will be able to build on the experience of other instructors. And at the bottom is my email, e3@greatusermanuals.com. And the slogan is to help keep our friends created in the image of God alive. If you want to find more on YouTube, that wonderful AOPA video that we showed earlier is on YouTube. And I did a 90-minute presentation to an EAA chapter on Zoom. And I tell you, it's just a whole lot of fun talking to a computer screen for 90 minutes. And this presentation that you're watching now should be on the web this evening. I mentioned research. For those of you who are in academia or looking for something else to study, there's a whole bunch of questions that I think are worthy of study. And that concludes the presentation. Questions?